In this section, we will talk about the area between curves. So first, a quick reminder that if we take the integral or the antiderivative of f of x from x equals a to x equals b, then that equals to big F of b minus big F of a, where the big F is the antiderivative of the function f of x. So quick review, find the area under the curve of y equals to 5 over x over the interval 1 comma 3. So if we graph this on Desmos, here's roughly what the function looks like. It looks something like this. And we want the area under the curve from x equals 1 to x equals 3. So when we take the integral, this is what we're looking for. We're looking for the area under this curve over here. Now, how do we do this? So the area under the curve is given by the definite integral. So we take the integral of 5 over x dx from x equals 1 to x equals to 3. Now, there are rules for integrals, and one of them is this, that we have to take all the variables and write them on the numerator using negative exponents if they're on the denominator. So this is 1 to 3, 5x to the negative 1 dx. And then, if we take the integral of x to the negative first, then this equals to the natural log of the absolute value of x. So this equals to x equals 1 to x equals 3. I'm sorry. So since we're taking the antiderivative, this equals to 5 times the natural log of the absolute value of x from x equals 1 to x equals to 3 by this formula of the antiderivative. So anytime we have x to the negative first, it equals to natural log of the absolute value of x. Now, we need the absolute value because the natural log, its domain, it's only greater than 0. So basically, x has to be positive. But if we're going from x equals 1 to x equals 3, we don't need the absolute value since both 1 and 3 are positive. So we can just rewrite this as 5 times the natural log of x from 1 to 3. Again, because from 1 to 3, x is only going to be positive. So this equals to 5 times the natural log of 3 minus 5 times the natural log of 1. That's f of b minus f of a. You can also put this into Desmos, and you'll get the area under the curve is 5.4931. Okay, so that's a quick review recap from the previous section. Now in this section, we're going to be taking the area in between two curves. So here's what that means. Let's say that we have two different curves, one that looks like this and one that looks like this. The area between the two curves will be represented by this shaded region. And that's what we want to try and find. We want to find that area. So step one, we want to find the limits of integration. So the limits of integration, so this shaded area begins at this x value and it ends at this x value. That's the shaded region, begins at this x and ends at this x. So these x values are given when the two graphs intersect. So when the two graphs intersect, we will solve that by setting f of x equal to g of x. When we solve that equation, we will get the 2 points where the graphs intersect, and those will be our limits of integration. So those are going to be our a and b values. Sometimes you'll be given x equals a and x equals b. Sometimes the problem will state, find the area between the curves, specifically between this x value and this x value, in which case you would use those as the limits of integration. Otherwise, you would find the intersection points by solving this equation. Then we want to find what is a function f of x minus g of x, where f of x is a function on top and g of x is a function on bottom. For us to do this, we need to graph on Desmos to see which is the top function, which is the bottom function. And you would take the top function minus bottom function in order to find what the area in the middle is. And then finally, we're going to take the integral from a to b, where a and b are the limits of integration, either that are found by finding the points of intersection or if they're given to you. and then we have f of x minus g of x, where f of x is the curve on top, g of x is the curve on the bottom. So let's see an example of this. We want to find the area between the curves y equals 4x plus 2 and y equals to x squared minus 3. The first thing we want to do is we want to kind of like get a quick idea of what these graphs look like. So go ahead and graph this on Desmos. Go ahead and graph this on Desmos. I already did that, and here's what I got. Y equals 4x plus 2. It's a y-intercept of 2, slope is 4 over 1, so it's going to look something like this. This is the curve y equals to 4x plus 2. And then we have y equals x squared minus 3, which looks something like this. Okay, and then this curve here is y equals to x squared minus 3. And I did this by graphing it on Desmos. We want to find the area in between these two curves. So the curves, they intersect at this x value and this x value, and we want to find the area just in between the two curves. So the area that's bounded by these two, not the area outside over here or over here, because this area is not bounded. It's not in between the two curves. So we just want to find the area that's strictly in between these two curves. So the first thing we need to know is, what are the x values? What's x1 and what's x2? So this bounded region, where does it begin and where does it end? At which x values? So these x values occur when the two graphs intersect. So we want to find out what are the points of intersection. And to do that, we simply set 4x plus 2 equals to x squared minus 3. And we solve that equation. So to solve that equation, we would move everything to one side because we got a quadratic. So we would subtract 4x, subtract 2. So subtract 4x, subtract 2. When we do that, we get 0 is equal to x squared minus 4x minus 5. If you factor this, this is going to be x minus 5 times x plus 1. Negative 5 times 1 is negative 5. Negative 5 plus 1 is negative 4. So we get x equals 5 and x equals to negative 1. So what that tells us is that this x value is negative 1 and this x value is positive 5. So we want to take the integral between negative 1 and positive 5. These will be the limits of integration. Okay, then step 2, we got to find what is f of x minus g of x. Because we want the area in between two curves, we got to subtract the top curve minus the bottom curve. So by the graph, we can see that the top curve is x plus 2, and the bottom curve in between these 2 points is x squared minus 3. So top, bottom. So when we subtract this, we get the top function is 4x plus 2. The bottom function is x squared minus 3. So if we subtract this, we're going to get 4x plus 2 minus x squared plus 3. And let's put this in order. So this will be negative x squared plus 4x and then plus 5. Okay, we got negative x squared plus 4x plus 5. So here's what we want to do. We want to take the integral, or the antiderivative, from x equals negative 1 to x equals positive 5 of f of x minus g of x. I'll rewrite it just to be thorough. So we got 4x plus 2 minus x squared minus 3. We always have a dx because we're differentiating with respect to x. If we simplify this, this is the antiderivative from negative 1 to 5 of the simplified function is here. It's negative x squared plus 4x plus 5 dx. Now let's calculate this. So the is equal to, now let's use the r plus 1 rule. So remember, if you have the integral of x to the r power, then this equals to x to the r plus 1 divided by r plus 1. So let's use that rule. So in the first case, our r value is negative 2. So it's going to be negative x to the 2 plus 1, which is 3, divided by 2 plus 1, which is 3. So it's negative x cubed over 3. Plus, we got 4. This is x to the first, so r plus 1 is going to be 1 plus 1, which is 2, divided by r plus 1, which again is 1 plus 1, which is 2. And then we have plus 5x. And this is from negative 1 to positive 5. For the last one, if you have the antiderivative or the integral of a constant, that just equals to kx. So if you put this into Desmos, put in f of x equals to negative x cubed over 3. This you would, of course, reduce to be 2x squared, and then plus 5x. Then put in f of 5 minus f of negative 1, and this will equal to 36. So the area under the integral is equal to 36. This shaded area is equal to 36.